Hi everyone, sorry I can't be here today. We're going to go through one question together kind of as a class with me kind of leading you through it. And then you should be able to do the worksheet projectile motion problems. Remember, these problems are nothing more than 1D motion Fab 5 problems that we do in the X direction and the Y direction. The only thing that's common between them is time. That's it. Other than that, they're Fab 5 motion problems. So the problem that we're going to do is a rock is thrown horizontally off a 100-meter cliff and it lands 95 meters away. At what speed was it thrown? So when you do these problems, a good suggestion, a good thing to do first is draw a picture. So we have a rock and a cliff. We have lots of room, so let's just make a big picture so it's clear. So we have a ball up here, rock, sorry, and we're going to throw it. And it's going to follow a curved parabolic shape, something like that. And it's going to land some distance away. And in this case, it's going to land 95 meters away. So that's what's going on. We got to figure out how fast was it thrown. Remember those questions we wrote on the board, and there should still be on the board, is you got to ask yourself, is this a 2D motion problem? If so, we got to make an X column and a Y column. So is this moving through both the X and the Y direction? Yeah. So we go through, we list our variables, delta X, VI, X, VF, X, A, X, and T. And we do the same thing for the Y. Delta Y, VI, Y, VF, Y, A, Y, T. Remember, these two are the same. The amount of time that it travels in the X direction is the same amount of time that it travels in the Y direction. Those are common. That's the only thing that's common between both of those. So first question, is it a 2D motion problem? Yes, moving through both the X and Y axis. 2D motion problem. Next question, is it a projectile motion? Is the object moving freely through the air in 2 dimensions? And the answer again to that is yes. So the statement we wrote on the board is, if it's a horizontal problem, the question we got to ask ourselves is, if it is a projectile motion problem, then we can make the statement that my acceleration in the X direction is 0, and the acceleration in the Y direction is negative 9.8 meters per second squared. Then, is it a horizontal launch? Is this object being thrown at some angle above the ground or horizontal to the ground? And it's thrown horizontally, so the ball is being thrown this way. If there was no gravity, the ball would just keep going straight, 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 and it wouldn't fall to the ground. But gravity is pulling it. So is it a horizontal launch? Yes, it's horizontal launch. So because it's a horizontal launch, then my initial velocity in the Y direction is equal to 0 meters per second. So I'm asking for the speed it's thrown. Well, I'm throwing it horizontally with some velocity in the X direction. I don't know what that is, and that's what I'm trying to solve. Because my acceleration in the X direction is 0, these two are common, and that's what I'm solving for, is my velocity in the X direction. Initial, final, they're the same. So when you do these problems, you got to make sure we ask ourselves this question. 2D motion, 2 columns. Projectile motion, accelerations. Horizontal launch, initial velocity in the Y direction. So that fills in a lot of information before we even start going back and doing our second readings. So a rock is thrown horizontally off a cliff that's 100 meters high. From here to here is 100 meters. And it lands 95 meters away. From here to here is 95 meters. So this distance traveled in the X direction is the displacement in the X direction. That's how far the rock travels in the X direction. It goes 95 meters to the right, positive direction. My rock goes from here to here. Now, if I define this to be my 0 mark, which is what we tend to do, my initial position is up here at 100. Delta, change in position, final is 0 minus my initial of 100. Or you can say, is that object going up or is that object going down? It's going down, so therefore negative 100 meters. Now, we're trying to solve for velocity in the x. If we have enough information, we could go and solve that directly. Remember, if you see an acceleration that's equal to 0 in the x direction, equation number 3 will be your friend. So delta x is equal to VIx times t plus 1/2 ax t squared. Since the acceleration in the x direction is 0, this whole term cancels out. And we're left with is 95 is equal to v, which is what we're solving for, t. I still don't know t. So we got to solve for t first. So we look over here and I say, hey, look, I got 1, 2, 3. I have 3 variables. I don't know final velocity. I don't care about final velocity. But I can go through and I can find time. Once I solve for time here, I can then plug it in over here. So we can go through and say, well, equation number 3 doesn't have final velocity. Delta y is equal to VI y times t plus 1/2 ay t squared, where my initial velocity in the y direction is 0. Plug in some numbers. Delta y is equal to negative 100, which is equal to 1/2 times negative 9.8 times t squared. Negative 100 is equal to negative 4.9 times t squared. Divide both sides by negative 4.9, and we end up with t squared is equal to. So then we grab our calculator and we say negative 4. Gotta turn it on. Divide both sides by negative 4.9. So we go negative 100 divided by negative 4.9. And what we get is we get t squared equal to 20.41. Now remember, that's t squared. So we take the square root of both sides, square root of my answer, and we get t equal to 4.52 seconds. Now I'm going to want to use that number later, so I hit store, and I'm going to store that as A, so we can come back to that. So my time is 4.52 seconds, and that's for both the x and the y direction. So once I determine the time in the y, that's how long it took to go from here to here. That's also the same amount of time that it takes to go from here to here. So I can come back to equation number 3 with the x direction, and I can say delta x is equal to, oops, I already got that. I can go delta x is 95 meters, VI is what I'm solving for, and my time is 4.52. Divide both sides by 4.52, and what I'm left with is VIx. So I can go through and I can take 95 divided by, and now I want to use that answer I stored, so I hit second store, which is recall, and then I say I want to use that number, so it plugs in and it pastes that entire number in there that I just stored, and I hit equals, and what I get is I get a velocity of 21.03 meters per second. So that's how fast the rock was thrown in the x direction. So it's going 21.03 here. If I were to look at it here, it would still be going 21.303. Over here, it would still be going 21.03 meters per second. In the y direction, initially, because it's a horizontal launch, it wasn't moving in the y direction. As it goes, it accelerates due to gravity at the rate of negative 9.8, and it's going to be going faster than 0. We don't know what it is. We could calculate it if we wanted to, but that's not what it's asking. So based on that, hopefully you can kind of follow through. These are Fab 5 problems. You just got to set up an X and a Y column. If horizontal launch, then my acceleration, if projectile motion, we know the acceleration in the X and the Y direction. Fill those two columns in. If it's horizontal launch, we can go through and we can plug in initial velocity in the Y direction to be 0. So You can watch me do them all you want. At some point, you got to practice these. So you got a projectile motion worksheet that will get passed out to you shortly. Work on those. Stay on task. Set up 2 columns. Don't get lazy. Write your equations. Make a list of your variables. Don't let anything from your x go into the 1 and the y. You can skip the problem for now about the river crossing. I believe it's number 3. You can skip that for now. It's not a projectile motion. It's 2D, just not projectile.